Today we're going to look at section 6.6, solving radical and exponential equations. Our objective is to be able to solve radical equations by raising each side to a power, and to be able to solve an exponential equation by raising each side to a reciprocal power. So what are the steps for solving a radical equation? The first thing we want to do is isolate the radical or radicals in some of the harder problems, and I'll talk to you about that. Raise both sides to the index of the radical, solve for x, and then check for our solutions and to see if there's anything called an extraneous solution. Checking our answers is extremely important here. I know I've told you to do that for any solving problem, but now you could get some problems that seem like they work, but they don't really work, and that's why we're going to check for those extraneous solutions. When we're solving ones for exponential equations, we're going to isolate the x term, and that x might be more than one term. Wherever x is, whatever has the exponent, then we're going to raise both sides to the reciprocal exponent, solve for x, and again check for our solutions or any extraneous solutions. So we're going to go through 6 examples. To save us a little bit of time, I have all the work already worked out. I'm just going to talk through it to make it hopefully a little bit better for you. So this is a radical problem because we have a root 3. So what the first step is, I want to isolate my radical. So what I'm going to do is add 2 to both sides. That's my first step. After I add 2, I want to get rid of the cube root. Well, I'm going to raise it to the power of whatever this index is. So since the index is 3, I'm going to raise both sides to the third power. And it's always nice to use parentheses to make sure you get everything. Now I'm just going to simplify. The cube root of 3 is x, and 2 cubed is 8. Now right now it looks like 8 is my answer, but you always want to do a check. And what a check means is you go back to the original problem. Don't move things from side to side. Anywhere you see an x, I'm going to substitute an 8 and then do the algebra. The cube root of 8 is 2, 2 minus 2 is 0, and that equals 0. So I can officially say my answer is x equals 8. Okay. My next example is an exponential equation because we have an exponent here. We don't have any radicals, even though remember this is equivalent to a radical. This is the same thing as the cube root of x squared, but we just changed the form. So the first thing I'm going to do is try to isolate this term. So I'm going to add 2 to both sides. Now that I get this, my goal is to get rid of this 3 halves. Well, to get rid of 3 halves and make it 1, because I want x to the first, I'm going to multiply by the reciprocal. But remember, we're multiplying the exponent by the reciprocal only. So my reciprocal would be 2/3. So I'm going to take 3 halves times 2/3, which means this side needs an exponent of 2/3. 3 halves times 2/3 is 1. And 27 to the 2/3 is 9. And again, just to remind you, this is the cube root of 27 quantity squared. Cube root of 27 is 3, 3 squared is 9. And that's where that solution comes from. So I want to do a check. I go back into my original equation. Anywhere I see an x, I'm going to substitute in a 9. Okay, 9 to the 3 halves, and you can use your calculator to do these checks. This means the square root of 9 cubed. Well, the square root of 9 is 3. 3 cubed is 27. 27 minus 2 is 25. Since both sides are equal, I can say my answer officially is x equals 9. In my third example, I go back to a radical problem. It's a little bit longer. As you can see, I have a few more steps. First thing I'm going to do is add 10 to both sides. Now the radical is still not alone because I have this negative 4. The big mistake students make is they add 4 to both sides because they see a negative 4. But you have to remember this is negative 4 times my radical, so the opposite operation would be to divide both sides by a negative 4. Now that I have the radical isolated, I want to think, what is the index? Now I don't see any number here, but remember the square root is an imaginary 2. So I'm going to now raise both sides to the second power, or square both sides. When I square a square root, I'm left with just what's inside, and negative 4 squared is 16. Now I just have a basic linear problem. I'm going to add 1 to both sides, then divide both sides by 2. Now you can write your answer as 17 halves, or 8.5. Since 8.5, you didn't have to round that decimal at all. That's acceptable. And it's probably going to be a little bit easier to use 8.5 in my check than 17 halves for typing it in. So now I'm going to go back up to my original problem. Anywhere I see an x, I'm going to substitute an 8.5 and then try to see, does the left side equal 6? And you can use your calculator for this. Just type this in how you see the left-hand side. You should get a negative 26. Negative 26 is not equal to 6. Okay, so what happened here? So what that tells me is that I don't have any solutions. This answer that they gave me is actually called an extraneous solution. It's a solution that just happens because I'm manipulating both sides. If you look here, originally I started with the square root. I magically squared it and now I have a linear problem. So sometimes by doing that, okay, I went from a problem that had an exponent of 1/2 to now an exponent of 1 for my for my x's. Sometimes it adds in answers that don't really exist, and that's why we always check. So for this one I should see an answer of no solution. So now I have another radical one, but this time I gave you two radicals, which makes it a little bit more difficult. Again, I told you to isolate the radical. Well, how do you do that when there's two? Well, what you want to do is split them. Put one on one side, one on the other. So what I'm going to do is add root 3x minus 1 to both sides. Now that I have this, I notice that the index of both are the same, both at 2. So what I'm going to do is square both sides. And when you square a square root, the nice thing is it goes away, so I'm left with a 2x on the left-hand side and a 3x minus 1 on the right. Now I'm just going to combine my x's by subtracting 3x from both sides, and then my last step is to divide by -1. But now let's double check and make sure this works. Again, I want to make sure that the left side is equal to 0, so I'm going to substitute in 1 anywhere I see an x, and just work through the algebra. I get root 2 minus root 2, which is 0. Since both sides are equal, I can say that x equals 1 is my solution. So let's go back to one of our exponential problems. So again, this one's a little bit more complicated. First thing I want to do is add 3 to both sides, and that's going to get me a -32. But I want to get rid of this -2, so again I'm going to divide both sides by a -2, which gets me a +16. Just like we did in the earlier problem, I have 2/3 here. The reciprocal of 2/3 is 3/2, so I'm going to take both sides to the 3/2 power. Now you have to be careful here. If you remember when we did our earlier section, anytime you took an even root of both sides, you had to take a plus or minus. So if you took the square root or the fourth root or the sixth root, you needed a plus or minus. That's really easy to see when you're dealing with radical form, but when you're in exponential form, it's a lot harder to notice if you're taking a square root, a fourth root, or a sixth root. But if you look here, remember when you have an exponent, the denominator is our index. And since our index is 2, that means I'm taking the square root of both sides. And anytime you take the square root, or an even root, you need a plus or minus. So that's where you're going to have to be careful here. What I'm really doing is taking the square root of 16 to the 3rd power. Well, I know the square root of 16 is plus or minus 4. If I take 4 times 4 times 4, I get 64, but -4, -4, -4 is -64. So I'm going to get a positive and a negative answer here for when I simplify this. If you type in the calculator, it will only give you the positive answer. That's why you have to understand that you did this to both sides, which in essence is taking the square root of both sides, which is a plus or minus. Now I'm going to get two equations. I'm going to get 2x plus 4 is equal to 64, and 2x plus 4 is equal to -64. And when I do that and subtract 4 from both sides, divide both sides by 2, I'm going to get two answers, x equals 30 and x equals -34. This means I need to do the check twice. The first time I'm going to substitute in 30. When I substitute in 30, my goal is to get a -35. If I do, it's an answer. And then I'm going to substitute in a -34. When I substitute in a 30 and go through all the algebra, I get a -35, which means 30 is a solution. When I substitute in -34, I also get -35. It doesn't always work where if one works, the other works. Sometimes both work, sometimes neither of them work, sometimes only one works. And if we do this, we find out that 30 and -34 are both solutions. Let's look at our last example. Back to a radical one. This one doesn't look that difficult because we only have one radical, and I've actually isolated it for you already. But the algebra students mess up. Okay, now that the radical is by itself, the index is a 2, which means I'm going to square both sides. When you square a square root, you just get 2x plus 7. But remember, when you square a binomial, this is the same thing as x plus 2 times x plus 2. We're going to have to distribute. What most students do wrong is they just write x squared plus 4, which gets them a wrong answer, which is a pretty big mistake in a math teacher's mind. Or at least in my mind it is. So now we have to FOIL, or distribute out, and we get x squared plus 4x plus 4. But now, how am I going to clean this up? Well, I have x squareds and x's, so what I want to do is move everything to one side and set it equal to 0. So I subtract 2x and subtract 7. Well, if I notice here, in our last chapter we spent a lot of time factoring. I looked at this as a trinomial, and I can factor it down to an x plus 3 and x minus 1. And this makes it much easier to solve if I set each parenthesis equal to 0, which is our zero product property, and solve, I get x equals negative 3 or x equals 1. Again, what I want to do is substitute in each one individually, but if you notice I have an x on both sides now, which means I have to substitute negative 3 on the left and on the right, and substitute 1 on the left and 1 on the right. If I do that, when I substitute in a negative 3, I actually get a 1 is equal to a negative 1, which we know is not true, so I have to write is not equal to. When I substitute in a 1, I get 3 is equal to 3, which is true. So one of my answers, my 1, became a solution, whereas negative 3 is considered an extraneous solution. So x equals 1 is my answer. Hopefully you feel a little bit better about solving radical equations and exponential equations, dealing with the idea of raising each side to a power.